Hey there, and welcome. Have you ever been on a bike ride, really feeling the wind pushing against you? Or maybe you felt that amazing thrill of just coasting down a hill, no pedaling needed. Well, all those invisible pushes and pulls, they're all around us, all the time, shaping literally every moment of our lives. They're called forces, and today, we're going to figure out exactly what they are and what they can do.
You know, this is the exact same feeling our friends Sonali and Rajani had on their bike ride. As they were flying down a hill, Sonali felt this mysterious pull. And that question she asked, what could it be? Well, that's our mission today. We're going to get to the bottom of these invisible forces that push us, pull us, and make our entire world move. So let's investigate.
So here's our game plan for this journey. We're going to start with the absolute basics. What even is a force? Then we'll explore all the cool things a force can do. After that, we'll dive into the two major types, contact and non-contact forces. We'll even see what happens when they go head-to-head, and finally, we'll bring it all back to the world right around you.
Okay, let's dive right into this first section. Before we can even begin to understand big ideas like gravity or friction, we've got to answer a really simple question. At its very core, what is a force?
I want you to just picture moving a simple cardboard box. You can push it away from you, right? You can pull it towards you, or you can lift it, which is really just pulling it upwards, away from the floor. In every single one of those actions, pushing, pulling, lifting, you are applying a force. It's really that simple.
So, here's the official sciencey definition for you. A force is just a push or a pull. That's it. And in the world of physics, scientists measure how strong that push or pull is in a special unit called the Newton, which is named, as you probably guessed, after the brilliant scientist Isaac Newton.
Now this is absolutely crucial. A force never just happens on its own, out of nowhere. For a force to even exist, at least two objects have to interact with each other. Your hand has to interact with the box. The wind has to interact with Regini's bike. You see? A force is always a two-way street. Okay, so a force is an interacting push or a pull. That seems simple enough. But what can these pushes and pulls actually do? This is where it gets really interesting, because now we get to see their incredible effects on everything around us.
What's really cool about this is just how different the effects can be. Think about it. A quick push from a baseball bat can totally change the ball's direction. A steady push on a balloon completely changes its shape. And that little pull you give your bike brakes can slow you down or bring you to a complete stop. Forces are incredibly versatile.
Let's just sum that up. A single force can start something moving, stop it, speed it up, slow it down, change its direction, or even change its shape. I mean, think about kicking a soccer ball. In that one split second, you take it from being perfectly still to flying across the field. You give it speed and direction, and you probably even squish it a tiny bit. That's the power of force.
Now, to make sense of all these different pushes and pulls, scientists basically divide them into two big groups. First up, you have contact forces, which are pretty obvious. The objects have to actually touch each other. And then you have the more mysterious ones, non-contact forces, which can somehow work from a distance.
All right, let's start with the ones we know best, the forces that happen through direct physical contact.
You know, the most obvious contact force has to be muscular force. This is the force you generate with your own body. It's exactly what Sonali and Ragini used to pedal their bikes. But get this, it's also working inside you right this very second. Your heart muscles are contracting to pump blood, and the muscles in your digestive system are working to move food along. It's pretty much the force of life itself.
Okay, here's another huge one, friction. Remember when Sonali and Rajani found it harder to pedal on those rough parts of the road? Yep, that was friction. It's the force that pops up whenever two surfaces rub against each other, and its one job is to oppose motion. But here's the crazy part. Without friction, you couldn't even walk. Your feet would just slip right out from under you. You couldn't hold a pencil because it would just slide out of your fingers. So this force that slows everything down is also the very same force that lets us grip the world.
All right, now for the weird stuff. The forces that can actually reach across empty space to push or pull. These are the non-contact forces, and they're kind of like magic.
So let's start with the puzzle I think we've all wondered about. You've felt it, right? You can feel two magnets pushing each other apart or snapping together, but they never actually touch. How is that even possible?
Well, the answer is magnetic force. It's this fundamental force of nature that creates an invisible field all around a magnet, and the rules are super simple. Poles that are alike, say two north poles, will always push each other away.
and opposite poles, a north and a south, will always pull together. All of this happens without a single touch.
Here's another really cool one you can try at home. If you take two balloons and rub them on a wool sweater or even your hair, they'll suddenly start pushing each other away. It's like they're allergic to each other. This isn't magnetism, it's another non-contact force called electrostatic force.
So what's happening? When you rub the balloon, you're actually scraping tiny, invisible particles called electrons off the wool, and they jump onto the balloon. Now the balloon has extra electrons, which gives it a negative charge. And just like magnets, charges have rules. Two negative balloons are going to push each other away. And this tiny little imbalance is the exact same force that, on a way bigger, more dramatic scale, causes lightning. Seriously. Instead of balloons, you just have water and ice rubbing together in a cloud, building up a massive charge that eventually leaps to the ground.
And now, we finally get to the force that answered Sonali's question from the very beginning: gravity. It's the ultimate non-contact force. And unlike magnets or static electricity, it only does one thing. It pulls. It always pulls everything straight down towards the center of our planet. That's the force that made their downhill ride so much fun.
Okay, so what happens when these different kinds of forces start to clash? Let's check out a classic battle. Gravity, a non-contact force, going up against the forces you find when you put something in water.
Anytime an object is in water, this amazing tug-of-war kicks off. You've got gravity, that non-contact force, pulling the object down, down, down. But at the exact same time, the water itself is pushing back with an upward contact force. We call it buoyant force. Now, if gravity's pull is stronger, the object sinks. Simple. But if the buoyant force is strong enough to fight gravity to a tie, the object floats.
The big secret to figuring out who wins this fight was cracked ages ago by the Greek genius Archimedes, and his principle is just brilliant. It says that the upward push from the water, that buoyant force, is exactly equal to the weight of the water the object shoves out of the way. Think about getting into a full bathtub. The water level rises, right? That's because your body displaced it. If your body weighs less than all that water you moved, you float. It's that simple. So let's just pull back for a second and look at the whole picture. We started this whole thing with Sonali and Regini on a bike, feeling that mysterious pull. We now know that pull was gravity, a non-contact force. We also know that the pedaling they were doing, that was muscular force, a contact force. And the thing that made it harder to pedal on the rough patches, that was friction, another contact force. We've seen that all these forces are just pushes or pulls. They're caused by interactions, and they can change everything about an object. From a tiny static charge on a balloon to the massive pull of an entire planet, forces are truly the invisible architects of our world.
And I want to leave you with this final thought to chew on. We learned that friction is a force that slows you down, which can definitely be a pain. But without that exact same force of friction, Sonali and Ragini's tires couldn't grip the road at all. So forces are rarely just good or bad. As you go about your day-to-day, start looking for the forces all around you. Are they helping you? Are they getting in your way? I think you'll find that a lot of the time, they're doing both at the exact same time.